Okay, so that we're still on those review sections, the last couple of sections for the whole class. We're almost done. It's kind of exciting. We did family of functions for quadratics. Family of functions will be polynomials and then rational functions. So all those will be those two will be for today. Polynomials, general power functions, and rational functions. Sorry, I'm still asleep. Give me a sec. All right, so let's go through this. So the degree of a polynomial is the highest power of that polynomial. So you just look at each term, look at the highest power. That is your degree. The coefficient on that highest power, or that term with the highest power, is going to be your leading coefficient. So in the homework, they're going to ask you what's the degree, what is the lead coefficient. Number three, then they're going to ask you about end behavior, and that's determined by degree, and it's determined if the degree is even or odd, and then if it's positive or negative. So there's going to be 4 permutations, right? So you have 4 different scenarios based on if it's even, odd, positive, negative. Just combine those 4 together. So if it is odd and positive, it's going to look like this. Again, this is the end behavior, not the whole function. So at the very end, it'll be going up on the right, down on the left. It could be shifted upward, right? But at the end, it'll be doing that. Number 2, let's say it is odd but negative. Just swap the directions. So if it's odd and negative, it'll be going up this way and down over here. Okay, now let's look at the even ones. If it is even and positive, it'll be basically think of parabolas, right? If they're even, they're going to be going upward. If they're even but negative, they'll be pointing down. Just like that. Okay, does that make sense? You don't have to memorize that, just put it on a note card or something. The question might have you phrase it a different way. So if it's odd and positive, they might ask you, well, what happens if x goes to infinity? Right? Well, y is going to infinity. It's going up. If x is going to negative infinity, the y values are going down. Negative infinity. So that's what they're saying here. Any questions on these ideas? I'll wait a bit. All right. You guys cool on this page? All right, let's do an example. Example 1. Given y equal to 10x squared minus 10x minus 5, what is the degree? What is the leading coefficient? Degree, leading coefficient, and end behavior. Okay. So highest power is 2, right? So degree is 2. What coefficient is on the highest degree? Right? It's right there, 10. Since it is even, the degree, and the 10 is positive, what is the end behavior? Right? So as this kind of shape, just pointing out. Is that straightforward? So let me show you the homework question in just a second. Because they asked this part a little differently. Because I mean visually that's what's happening, but they ask it more legit, I guess. In my informal math sometimes. So degree 2, coefficient 10, but check out down here, number 2. What is this? Let me hit share so the video will record it. 1 second. Okay. All right. So the degree is 5, correct? So I'm just gonna write down example 2 here. Given, let's write this guy down. Y equal to negative x to the 5th plus 2x to the 4th plus 6x. What is the degree? Let's go ahead and write that down. What is the lead coefficient? Because we need those two things to talk about end behavior. So the degree, we said it's 5. The lead coefficient is -1, right? So what I want you to see right here, this is asking you as x goes to negative infinity, meaning left direction, right? What is the y doing? Yeah. If it's odd and negative, we have this shape, right? Let me switch back in just a second. Okay, give me one moment. Turn that off. There it is. Having technical difficulties. Okay, so what this is saying here, right? As x goes to negative infinity, the y value is shooting upward towards the left direction. So that means that y goes to infinity. That is what this is saying. Right. Let me, you know what, let me write this better. as x goes to positive infinity, y goes to negative infinity. That's why we have this shape. Does that make sense? How the homework is asking the question. Okay, this just means you go left direction. So as I just look at the graph. As I go this way, this is going up. As I go to the right, it's going down. Any question on number 2 or 3? Oh, sorry, 1 or 2. There's no 3 yet. Okay, let me give you a note, another note. Number 1, the maximum number of turns on a polynomial is n minus 1, where n is the degree of the polynomial. Number 2, the maximum possible zeros of a polynomial is equal to its degree. I mean, that's not guaranteed n, it's the maximum. All right. What is the least possible degree of the following? See if I can fit it here. Okay, so number 1 says the max number of turns. Well, what is a turn? So the function, see how it turns here once, and then twice? That's what I mean by turns. So it's shifting. So the degree could equal 1 more than the total number of turns. We have 2 turns, so this should be at least 3, degree 3. Now, it could be more, but at least 3. We also said that the possible zeros, the maximum possible zeros, is equal to the degree. So this could be, so that also points to degree 3, right? You see the zeros? Does that make sense? Do you see why the degree must be at least 3? It could be more. It could be degree 5, but at least 3 means 3 or more. That's all. The one last topic for this section, we'll move on to something else. It's multiplicity. So you guys, any questions on degree, leading coefficients, or end behavior? That's straightforward? That makes sense? Okay. Oh, wait a second. You guys good? All right, so one more note here. A zero of even multiplicity will have the graph bounce off the x-axis. So it's not going to, so when it gets to the zero, it'll just bounce off of it. Keep going. Only if it has even multiplicity. A zero of odd multiplicity will have the graph cross. Uh, bounce. This one? Bounce. So it just touches it and keeps going. It doesn't cross the point. So example 4 says find the zeros and give the multiplicity. Of f of x equal to x cubed times x minus 8 cubed times x plus 8. Okay. So to find the zeros, you set this whole thing to 0, right? So each piece equal to 0. So what I want you to see is that when they say a 0 has multiplicity, it means it's being multiplied multiple times. So you guys see that this is 3x's, right? So no matter what, x is 0, but there's 3 of them. Over here we have 3 as well. So when you solve it, you should know that 8 has multiplicity 3. This has multiplicity 3. This guy has 2. Of course, we don't write them out like this. I'm just showing you. So the multiplicity of x equals 0 is 3. Multiplicity of x equal 8 is 3. Multiplicity of x equals negative 8 is 2. So if you put all the ideas that we just talked about together, we can do a sketch of the graph. Now, if you count the powers, this is 3, 3, 2, right? That's degree 8. That's degree 8. And it's positive, so the end behavior will be pointing up. It'll be doing something like this. Something like that. Now we have a 0 at 0 and at 8 and negative 8. Might have to redraw those arrows, but it's okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have a 0 there. Now, since I'm have the end behavior going up, right? That means as I approach this 0, because it is multiplicity 2, I'm going to bounce off it. Okay. Then I'm going to come back down at some point, I don't know when, and cross this 0. Then I'm going to come back up somewhere and go back up this way. So the end behavior tells me it's doing this. Maybe that's too high, it looks weird. So I bounce, cross, and cross. Again, this is a sketch. These numbers probably go way higher because it's a high-powered function. These tick marks are probably like, I don't know, in the thousands or something, or hundreds. But you can see with all those ideas, you could sketch your graph. Just have an idea of what does it look like. Anyway, any questions on polynomials?
So the reason why it bounces is
Yeah, so if it's even, it will bounce. This one right here tells us. So even, so cross, bounce. But that's pretty much it for that section. They shouldn't ask about anything else. Just degree, leading coefficient, end behavior, and multiplicity. They may have a graph, so you got to figure out what degrees they are by looking at them, looking at the graph. I think that's it. Is that straightforward? It should be very familiar from college algebra. Hoping you've seen this before, and if not, well, we're talking about it now. And I'll wait a sec. Move on to the next section. Okay, so new section. So it's still family of functions, but now it's rational functions. Okay. Just a reminder, to find the domain, of a function, you must determine what is not defined. It's pretty much what we've always done. You look at a function and figure out, okay, what is excluded, what is allowed, whatever is not allowed, you'll create the domain around those points. Okay. So you're always working backwards with domain. So first couple of examples ask you about the domain. So find the domain of f of x equal to x squared plus 9x plus 18 over x squared minus 2x minus 15. So to find the domain of a rational function, set the denominator equal to 0. And find the x values that are not allowed. It's basically what we are doing. So you're going to take that x squared minus 2x minus 15, set it equal to 0, solve it, and you'll know those are the two numbers that we cannot use. Set that guy to 0, factor this, that'll be x minus 5 times x plus 3. So x minus 5 equals to 0, x plus 3 equals 0, x is 5, and x is negative 3. So those are the two values that you cannot use, because we asked the question, when is this equal to 0? Well, that's equal to 0 when x is 5 and x is negative 3. So that causes problems for the rational expression. So you're always going to ask that same question, like, where's the bottom 0? Okay. So using that information, I recommend make a little number line. These are the holes of my function. Continuous everywhere except there. So you'd say negative infinity until negative 3, negative 3 to 5, and everything after 5 is fine. Okay, so I put parentheses because we're not including them. Brackets would include, which is what we said can't happen. So negative infinity all the way until negative 3. Stop right before negative 3. That's what parentheses means. 2.999 is fine. but not -3. In between these two are good, but not the endpoints, right? Because these are parentheses. Everything right after 5 is fine, but not 5. No brackets. Is that clear? So once you have that, just put it all together with the intersections. Because the homework does ask for interval notation, which is this. Is there any questions on number 1? Okay. Let me give you some notes about asymptotes, because the homework's going to ask for domain, vertical asymptote, horizontal asymptote. And one more thing. I forgot what it was. Something. I think that's it, actually. No, we'll see. Oh, you're talking about. Okay, so let me give you a bunch of notes. Number 1, vertical asymptotes. So vertical asymptotes happen whenever an x value causes division by 0 on a rational function. So just say you write it like this: x equals to whatever that number is. Okay, some number. On the homework, you have to write it as an equation. Now, horizontal have 3 different scenarios. Given a rational function of this form, ax to the n plus some garbage, bx to the m plus some garbage. So we're looking b. All right, so here's the 3 scenarios. So scenario A, if the degree, I'm gonna try to shorten this up, n is less than m, then the horizontal asymptote is y equal to 0. So in plain English, we're saying if the degree on the bottom is bigger, horizontal asymptote is y equals 0. B, if the degrees of the numerator slash denominator are equal, then the horizontal asymptote is y equal to a divided by b. So you take the lead coefficient of the top divided by the lead coefficient of the bottom. That's it. If the degree of the top is bigger than the bottom, then there is no horizontal asymptote. You would have an oblique in this case. They don't ask about this, I'm just letting you know. It's an oblique or slant asymptote. All right. Write one more note here. Discontinuities are removable if the rational function has factors that cancel the factor I should have phrased that. In the denominator. Yeah. Okay. So let's go through a couple examples and we'll be finished. So discontinuities, meaning holes in your function, can be removed if the rational function has factors that cancels the factor in the denominator. So basically, if you factor the top, that cancels something on the bottom, then we can consider that removed. It's no longer division by 0. And I think they'll go deeper into this in calculus 1, more formal. Are you guys cool on this page? Example 2, given f of x equal to 10 over x plus 10. Find the domain vertical / horizontal asymptotes find those three things. So you should find the domain first. It'll make this a little easier. So let's find the domain right here. In order to do so, set the denominator equal to 0. Solve for x. So we know that this is the only problem area that we have. So just create an interval before and after, and then just glue it together. Negative infinity until 10. Oops, negative. Negative 10 until infinity. So the domain is these two pieces. The vertical asymptote is the equation that causes that problem. So you always write x equal to some number, which is going to be negative 10. Don't just put negative 10. Horizontal asymptote. We said that depends on the degrees of the top and bottom, the numerator and denominator. The top degree is 0. The bottom degree is 1. We said if the bottom is bigger, then the horizontal asymptote is y equal to 0. I'll make a note here, because the denominator has a higher degree. Is that clear? That's all they asked for. Example 3. That's cool on example 2. Okay. So given f of x equal to x squared plus 10 over x squared plus 6x, find the same stuff. Find the domain, vertical, and horizontal asymptote. There we go. Same question. So first step, find the domain, and that should give you the vertical asymptote right away, because you got to work around the asymptotes. So domain right here, the x squared plus 6x equal to 0. Factor. So that gives us that x is 0 and x plus 6 is 0. So x equals to -6 as the other problem area. So -6 has a pole, 0 has a pole. So before -6, we're good. In between, we're good. After, we are good. Okay, so answer the question. Just glue all those three pieces together. The domain will be -infinity to -6, union, -6 to 0, union, 0 to infinity. Vertical asymptote is simply going to be x equal to those two poles. So x equals -6 and x equals 0. All right. Horizontal depends on the degrees of the top and bottom. We said that they are equal, right? We have a 2 and a 2. It's the highest degrees of the numerator and denominator. So we have to do y equal to the coefficient of the top of the highest degree divided by the coefficient of the bottom, which will be 1. This is because the degrees are equal. For the numerator / denominator. Any questions on number 3? Is that okay? I'm hoping it's review. But let me know if there's any issues, or if you forgot something. Right, one last example. I need to talk about continuity. I'll wait a bit. Last example for today. Right here. So I'm gonna write that question down. Given that f of x is equal to x squared minus 100 divided by x minus 10. Identify the removable discontinuity. Okay. All right. So all you have to do, we said, is if you can factor and cancel the term, then that is your removable. So you take this guy back to the top. You see that that is the difference of squares, right? This will factor into x plus 10, x minus 10, difference of squares. So these will cancel. So the removable discontinuity is x equal to 10. Because originally, plugging in 10 at the bottom would cause division by 0, correct? But now it's gone, so I can plug in 10, kind of. So we consider that a removable discontinuity. Is that clear what removable means? The last couple of questions are just asking you to find that x value. So you just have to factor. That's it. And that's pretty much it for that section. Does have any questions on polynomials or rational functions? Is it clear? I'm gonna take roll real quick and run off just yet.